Welcome to my channel. This video shows the design and analysis of a CMOS low noise amplifier in Cadence Virtuoso. Low noise amplifier is created with two NMOS transistors and passive elements like resistor, capacitor, inductor and input ports. NMOS transistors has a width of total width of 60 micrometers, finger width of 6 micro, total number of fingers is 10. 10 multiplied by 6 micro will lead to 60 micro. Similarly for the second transistor, 10 fingers multiplied by 6 micro, total width is 60 micro. The port has a input resistance of 50 ohms, source type is sine, frequency of 2.4 gigahertz. That means I want to measure the response at 2.4 gigahertz frequency. The input source is a 1.2 volt and it has a source inductance of 1 nanohenry followed by 5 ohm. The inductance is 200 picohenry. The resistance is 50k ohms. The source voltage is 600 millivolts for this particular CMOS low noise amplifier, and it has a DC capacitance at the input and output to block the DC and allow only the AC components. Once the design is complete, check and save the design. Go to the launch, click on ADE Assembler, create new view. OK. It opens the view as Mastro to handle multiple analysis. On the left you have a data view. Click on the test, then select the test you want to perform or load the test. Then select the type of analysis that you want to perform. Click the analysis. I want to perform a transient analysis for 10 nanoseconds. Apply. Similarly, I want to perform a S parameter analysis. Click on select, then click on the ports. Once these are defined here, you can start simulation from 100 megahertz to 5 gigahertz with a linear sweep type. Number of steps to 50, and you can add DC analysis as well. Right now I am performing 3 type of analysis here. Then try to add the input and output for transient as well as the S parameters. So click on expressions. You have the calculator here. To load the S parameters, click on SP, then select the port at the input side, and you can just click on this. Or go to the Mastro view, click paste calculator buffer. that expression will be added, the same expression. For the transient analysis, I'll use the same. Let me clear all this. Clear the buffer. Since it is a transient analysis, click on V transient, voltage transient. Select the input, then click on this so that it gets added into the master view. It is added at the input. Similarly, erase this again. Click on VT again. Select the output. Again click on this gear symbol so that that expression goes into the ADL or master view. All the three expressions are loaded here. Once these are done, go to the from ADE Explorer view to move to ADE Assembler. This is like check-in and this is like checkout. Now you have three expressions to be evaluated. Once this is done, all the analysis are loaded. Click on here to run the simulation. This has performed the S parameter analysis, DC and transient all at a time, at a single instance. You can see the low noise amplifier with the DC. Plot this or click on this to see the response plot for transient as well as S parameters. You delete this. Change the graph properties to white background. This also. Change this color also. And measure the value here. This is the response at 2.45 gigahertz frequency. This is the response for transient and this is the response for S parameters of a low noise amplifier.